stars today. Unit 10, day 4. Oh, you know what we need to do before this, though? Pause. Inverse trig functions. Inverse in math class, well, I guess anywhere, basically means you're kind of working backwards. So today I'm going to give you the answer and ask you for the angle. So you still have to know the unit circle, but you have to know it, I guess, well enough to go backwards with it. Trig is sine, cosine, tangent. We know what that is. Functions, this is an important part of the title. Functions give you one answer. Right? When you think back to if something is a function, that means it only has one output. You might have talked about vending machines in Algebra 2, where you push a button and you only get one thing out. Like, that's what a function is. You don't get two outputs. I mean, if you get 2 or 3, that's great for you, but that's not a functioning vending machine, right? That doesn't work. Functions have one answer. That's where we were. And if you get more than one answer, that's great from a vending machine. If you get 2 Cokes, or a Coke and a Dr. Pepper, but that's not a functioning vending machine. You're only allowed to have one answer. Okay, so let's actually look at you're familiar with this, and you're familiar with it in a confusing way. If that x squared equals 9. So that's an equation. It's not a function. If x squared equals 9, what are my answers? What does x equal? 3 is one of the answers, but there's something else that I could square to get to 9. Negative 3. So plus or minus 3. So that's an equation. It can have more than one answer. But if I have a function like just the square root function, and I want the square root of 9, it can only be 3, because we're only allowed to have one answer. Even though if you square negative 3, you get to 9, we're only going to pick one answer. And so there was a pre-cal committee convened long ago, and they said, you know what? It would be dumb for us to pick negative 3. Let's pick the positive 3. And so we just decided that if the square root's already there, we're going to pick the positive answer. If it's an equation, there could be more than one answer. But if we're answering this question, we only get one answer. The square root is a function, therefore only one answer. So we sort of have a restricted output, a restricted range. Right? Our answer has to be positive if we're doing the square root function. Even though we know there's some other stuff that's kind of going on, we've decided we only want the positive one because that's the one that makes sense. Okay, that's the concept. We're going to carry that concept over to sine and cosine and tangent. In fact, I'm trying to lay these out in a parallel structure here. So sine of x equals 1/2. That's an equation. It's asking you what angle, or angles, plural, have a sine of 1/2. So we definitely know it's over 6. It's not anything over 6. So pi over 6 is one of the answers. 11 pi over 6 would be down there, and that would be negative. Sine's positive, and if sine's positive, it's got to be in the top half. You said almost 1, so 5 pi over 6. And there's even more answers than that. If you really want to get creative here. 10 over 6 wouldn't work.
Couldn't you go negative numbers?
You could go negative, like the angle I just drew. So that'd be a little more than pi. That'd be negative 7 pi over 6.
Or couldn't you just add another 2 pi?
And you could keep adding and subtracting 2 pi. So where all my colored pins go up here. You go backwards almost all the way around, that'd be negative 11 pi over 6. So how many answers are there to this question?
A lot.
A lot. Like I did 4, but I could spin around. I could add 2 pi and 4 pi and 6 pi. And so there's an infinite number of answers to that question.
How many answers do we have to have?
Well, we're not doing equations today. We're doing inverse sine. So that's kind of good news because I only want one answer, the inverse sine of 1/2. Now, out of the infinite number of possible answers, the pre-cal committee convened, and which one do you think they decided would be the best choice for this problem? Pi over 6. So the good news is there's only one answer, but it's always the answer that makes the most sense. It's always the easiest answer, the shortest answer, the quickest answer to get there. So you're never going to pick an answer that's, going backwards 3 times around. Like, no, you're going to pick the easiest answer. I guess you should back up. What this means is, or how we say that, is the inverse sine of 1/2. That means find an angle whose sine is 1/2. Go backwards. That's the inverse part. So you got to know the unit circle well enough to think backwards to get the angles. So you know everything you're supposed to. If you know everything you're supposed to know, today isn't that bad. Although that might be a big if. How about the inverse sine of negative root 3 over 2? So if sine is negative, which quadrants have a negative sign? Again, maybe pictures help. So definitely going to be in the bottom. Root 3 over 2 is the long side, so that would be the steep angle. So this one may be a little bit confusing, because which is the easiest explanation? It's something over 3 because it's the steep angle. Okay, so 4 over 3 is not the right answer, but the sine of 4 pi over 3 does equal this, so you're not completely wrong. But when the committee convened, they decided they would not pick 4 pi over 3. They would say, you know what, the easiest way to get there, sure, we got to go backwards, but the easiest way to get there is to go backwards negative pi over 3.
So you always take the shortest distance?
Always take the shortest distance,
So there's always going to be
except for cotangent.
Wait, so is there going to always be a pi on top, basically, negative or positive?
Yes.
Oh.
I mean, you could still have a 2 pi on top, or 5 pi on top. We'll see that in a minute.
It's a bit confusing.
Inverse sine has a restricted range. So here comes the official formal answer. But if you'll just get there the quickest way, you'll get the right answer, even if you don't understand or memorize this sort of formal language of restricted range. I'm going to draw the picture of it first. Inverse sine is coming from first or fourth. If it's positive, it's in the first quadrant. If it's negative, it's in the fourth quadrant. Negative pi over 2 to pi over 2. But again, I always felt like it makes sense, so you don't have to memorize this. Just pick the closest, simplest, quickest answer. Don't be doing something crazy. Pick the best answer, and you'll be right 99% of the time. All right, let's do the same thing with cosine of x equals 1/2. We'll walk through the same steps. We'll go a little quicker because we're kind of used to it. Where's the cosine equal to 1/2? Give me some. When it's over, see, cosine's the x coordinate, 1/2 is the short side. So this is going to be a steep angle. So pi over 3. What other quadrant has a positive cosine? Yep, quadrant 4. So that'd be 5 pi over 3. If we go the long way around. Get creative and go the short way around. We could do negative pi over 3. Go backwards all the way to the first quadrant. That'd be negative 5 pi over 3. And yes, you can add 2 pi to any of those, or any multiple of 2 pi to any of those, and get an infinite number of answers. Whoops. But when the pre-cal committee met, they didn't invite me, but they decided that the inverse cosine of 1/2, out of all of those answers, which one do you think they said, you know what would make the most sense is if we just said the answer was pi over 3. So I wasn't invited, but I agreed with their decision. That's a good pick.
Who's on the pre-cal?
It's a completely fictitious, sort of like the Illuminati, though. It's like, does it really exist? How did they make those decisions? No one really knows. It's a secret society. How about the inverse cosine of negative 1/2, though? Well, be careful. Negative pi over 3 would have a positive cosine. Can't be there. It's got to be in the second or third quadrant. So when the committee met, what answer do you think they decided should be the best answer for this question? Yeah, some of you are ready to be on this committee, apparently. 2 pi over 3. Right? Because why pick 4 pi over 3 if you could pick 2 pi over 3? And negative 2 pi over 3 works, but why would you pick the negative if the positive one works? I'm going to submit some of your names to this committee, so all future decisions you can have an input on. So inverse cosine has a restricted range. Well, everything is coming from the first or second quadrant for cosine. So that would be 0 to pi. Correct. The answers will only be in those 2 quadrants. The answers to an inverse cosine problem. Sort of like the answer to a square root problem will always be positive. Even though they're sort of kind of negative answers, but we said, you know what, we only want the positives. For inverse cosine, we're only going to come from quadrant 1 or 2.
What about negative sine and then inverse sine?
So inverse sine could come from 1 or 4. And you have to pick the 2 quadrants so that you get a positive value and a negative value. All your values have to be covered. So for sine, that's 1 and 4. For cosine, that's 1 and 2. Okay, a little bit of practice here before we do tangent. Inverse cosine of negative root 2 over 2 and inverse sine of negative root 2 over 2. All right, so inverse cosine, with that answer was 3 pi over 4. This one was negative pi over 4. Let's do the same process with tangent. We'll start with an equation. Where does the tangent equal 1? Tried to pick an easy one, hoping you would know this.
Oh wait, it's y over 2, so.
It's over 4. That's a great first.
Oh yeah, that's right.
It's a great start because it's the one in the middle. So what over 4 is it?
Would it be all of them, right?
It's pi over 4. But it's not all of them because it's negative in the.
Only be in the first and fourth.
There was a all students take calculus reference in first period, if that helps. So tangent is also positive in the third quadrant. So 5 pi over 4. Those would be your two normal answers. You could start getting creative and say negative 3 pi over 4, negative 7 pi over 4, and you could add 2 pi to any of those, or 4 pi, or 6 pi, or 8 pi. But you get the idea. Well, once again, the pre-cal committee reconvened and said, well, we've got to figure out which answer we want if we're taking the inverse tangent of 1.
How do you know they just didn't do this at one meeting?
Oh, it took several meetings. It's very contentious. Yeah.
Pi over 4.
That would be pi over 4. They definitely picked pi over 4.
So the answers are only in the first and third quadrant? Or like that's restricted?
The restricted, well, I don't need the third quadrant because the first quadrant is where my positive numbers come from. The trick is if tangent is negative, so let's do the inverse tangent of, let's do one where we have to think a little bit here. Negative square root of 3. Oh. So it's got to be in the second or the fourth, right? Because tangent's negative in the second and the fourth. And this is where the people that memorize the tangent 3 trick are at a little bit of an advantage, because they know that if the answer is root 3, the denominator is going to be 3. 3 is the steep angle. And so this is where the major debate happened at the meeting. Because it's like, well, one's quicker, but one's positive. And so they fought it out for a good long while. And which one do you think they picked? The negative one. Like, let's just get there the quickest way possible. Let's do negative pi over 3. So some people left with their feelings hurt that day. The ones that didn't like the negative numbers. But as you can imagine, anybody that goes to a pre-cal meeting is comfortable with negative numbers, so they said, all right, we'll use the negatives.
Why is that the exception? Why not do it all of them? Oh, it should be the positive one, if you can.
We want to get there as quick as we can, though. That's always the right answer. Get there as, well, shoot, cotangent's not quite.
Wait, can you...
Wait, so the only one...
Can you re-explain the square root trick?
Yes.
Jog my memory.
Yes, the tangent 3 trick is that the tangent of anything over 3 is the square root of 3. The other way is the tangent of anything over 6. Well, 6 is 2 3s, so I need 2 3s in my answer. I mean, that's just a fluke, but that's how you remember the tangent 3 trick. Especially helpful for going backwards.
So the right way is always the fastest way, except for with cotangent.
Correct.
So I can apply that to my short.
So inverse tangent has a restricted range of first and fourth quadrant. So negative pi over 2 to pi over 2. What's the difference between sine and tangent's restricted range? Very subtle.
There's a positive
They're
negative on
swapped.
top.
They're positive.
Between sine and tangent. Wait, that's wrong. That's yeah. You're like the positive and negative swap. That's not true. Yeah, no wonder you were confused. Now, what's the subtle difference? The correct subtle difference between sine and tangent's restricted range?
That's positive and negative, right?
That's a positive. Everything in the first quadrant is positive.
Yeah.
So the question is, where do you get the negatives from? That's the real issue. But what's the difference? So we hadn't hit it yet. The difference between the restricted range for sine and tangent. It's really subtle, but we've dealt with this before. whether they're included or not. Tangent's got parentheses, sine has brackets. Why are we not including pi over 2's for tangent? Do you know?
No.
It doesn't really come up, but it is kind of interesting to some. Certainly everybody that was on the committee found this interesting.
This committee needs to.
Do you know what the tangent of pi over 2 is?
No.
Y over x is right there.
Wait, no.
Undefined, and so you can't really use pi over 2. It's not really an issue because we're never going to ask you for the inverse tangent of undefined. That's not a thing. I guess we could say where is it undefined, but we wouldn't say inverse tangent of undefined. Well, then someone at the committee got the idea of, you know what, let's just kind of summarize this and say that quadrant 1 and quadrant 4, that's sine and tangent, and then almost always with sine goes cosecant. And quadrant 1 and 2, we'll use that for inverse cosine and inverse cotangent and inverse secant. Yeah, that's, if you need to memorize something, that's the picture that you memorize. So there's sort of two methods. The first method is, just pick the one that makes the most sense. The other method is, well, let's be a little more precise, honor the work of the committee, and think about quadrants, which ones we're allowed to use.
So those are right where the answers will be, right?
This is where your answers will be. In fact, so which quadrant are we never allowed in?
The third?
I believe I've heard Mr. Conley call this the quadrant of death. You die if you go in the third quadrant. That also means you never land there, but you also never go through there, right? So if you're in the fourth quadrant, you're not allowed to go through the quadrant of death because you'll die. You have to go backwards into the fourth quadrant. Your answers will never come from the third quadrant. You will also never go through the third quadrant. That takes too much time. I don't have time to go through the quadrant of death. Kidding me? It's terrible over there.
No, I'm not daring.
All right, how about the inverse cosecant of negative 2?
My brain does not have this power. Okay, that's sine. So
That's sine, so I don't want to worry about cosecant, so let's make it a sine problem.
1 over sine.
And how are sine and cosecant related to each other?
So 1 over 2?
1 over 2, or negative 1 over 2. So yeah, I'm not working cosecant problems. I'm still not working cosecant problems. I'm working sine problems. So where is the sine negative 1/2? Careful, sine's got to...
I read fourth, I think.
Sine's negative in the down.
Okay, and then
Fourth quadrant.
so it's be like negative?
Negative pi over 6.
Is that all you have to do?
Uh-huh.
Wow, okay, let's help, don't make it any more confusing.
Wait, so you don't have to write like the restricted range?
Nope. That's, you have to use that. You have to know that. But your answer is just going to be one angle.
Oh, okay.
Okay? Sorry, I didn't make that
I like her.
clearer.
That's all.
Okay. Cotangent is the trickiest one. Cotangent is the trickiest one.
But it goes with quadrant 1 and 2.
It's got to come from 1 and 2. That's a good way to answer this question first. So I'm not allowed to look anywhere else.
Well, can we just make it?
If cotangent is negative,
Oh,
it's
but-
not in the first quadrant because first quadrant is positive for everybody. So I know it's going to be in the second quadrant. Now I just got to figure out where is the cotangent square root of 3.
But you can't change it to tangent.
You kind of can as long as you still stay in the second quadrant. So I want to know where the tangent is equal to root 3 over 3. Because of the flip thing. Sorry, negative root 3 over 3. That's the over 6 rule. So I need over 6 in the second quadrant. 5 pi over 6. The trouble with cotangent is if you switch it to cotangent, if you switch it to tangent, that's fine, but you still have to use the restrictions that are on cotangent. Right? Because tangent is negative in the fourth quadrant, and if we were asked this question, we'd give the fourth quadrant answer, but cotangent can't come from the fourth quadrant. So cotangent is the only one that's a little bit weird. All right, arc sine. So that's a new word. But all it means is inverse sine.
Okay. Is that a 0?
Of 0. Arc sine of 0, which means inverse sine of 0, which means find me an angle whose sine is 0. And this one person in first period said, oh, it's the one on the right. I'm like, well, yes, right? It's the one on the right. I'm like, yes. What angle is that right there?
Well, it could be 2 pi.
It could be 2 pi, but I'm not allowed to use 2 pi. I need to use the simplest angle there is. 0.
Woo, that was easy.
Mary's ready to be on the committee. I'm going to submit her name for.
Just have that question on the test over and over and over again.
Arc cosecant negative root 3 over 3. That's kind of as bad as it can get. Because my handwriting's bad. It's cosecant. It's negative.
It's cosecant.
Who is cosecant friends with? Partners with? Sine. And sine, they are reciprocal friends. So we'll flip that over. Except that doesn't look like a unit circle value now.
Oh, but you can't have.
But it kind of is.
You can't have the.
Because if you fix the square root of 3 thing, you end up with negative root 3 over 2. Because this is what cancels. So where is the sign equal to negative? So that would be down. Can't use the third quadrant, so it's got to be in the fourth quadrant.
So could that be
Root 3 over 2, that's the long side.
wait?
So I need the steep angle, fourth quadrant.
1/2.
It's got to be over 3. And negative pi over 3.
That's what I'm thinking. I just keep saying.
Because you got to get there the quick way. 5 pi over 3 is going to be a common wrong answer for that one. Because people are going to do everything right, identify the fourth quadrant, the steep angle, and they're going to go the long way around. They think they can traverse the quadrant of death, and they will lose
How many
points.
points do we take off? Like a lot?
No, that'll be like half credit if you put 5 pi over 3 there.
Is that it?
Last one. We got 6 minutes, man. We're fine. Arc cosine of 1.
Wow. Okay. Cosine.
So that means where is the cosine equal to 1? What angle has a cosine of 1? You confidently said it, and you were confidently in the right place. 0. Not 2 pi, because why would you go all the way around when you don't have to go anywhere?
Okay. Oh, wouldn't it also be negative? All right, now it's y. Wait.
Do you? Okay, last one then, because I know. What's the inverse cosine of negative 1?
Well, I don't think you know how to count.
Okay, well that would be. No,
Pi, because it would be on the left, also known as pi. I love the answers. That's on the left. Like, well, yes, but you know what angle is on the left.
Let's just write this.
All right, worksheet 4. It's all unit circle stuff. If you just pick the easiest, quickest answer, you'll be right most of the time. Cotangent is the one that's a little bit weird.